Okay. Okay, so let's have the class. Okay, so let's begin the class. In today's class, we will finish the part about the lighting. Okay, and after that, it means we finish everything for computer graphics. And for the lecture on Thursday, I will give you some final project that you have to finish, and you have 3 weeks. Okay, 3 weeks to finish the final project, and then submit it to me. Okay, and for the final project, there will be 2 parts: the basic part, which required by everyone, and the advanced part. For the advanced part, there's several topics, and I will assign each topic to several students. I mean, the final project is not teamwork; it's individual. So you have to finish that by yourself. Okay. So for the basic part, if you finish the report, you get some basic marks. If you can finish the advanced part, you will get some additional mark for this course. Okay. And I will talk about it in next class on Thursday. That's for the final project. So first, let's finish the part for the lighting. We don't have too much, so let's finish it now. Last time we have talked about the lighting, right? In terms of lighting, there are several issues we need to think about. The first is the light, right? Now we have created a small cube, to represent the light, which means if you run the code, let me run the code again. Yeah, so you can see we have simulated this white cube to simulate the light. Now let's try to simulate the lighting. And according to our equation, which I will briefly recall that, is here. Let me see. Let me find it out. Shading. Let me find the shading. Okay. Shading part. If you still remember it, if we want to get the shading, we need to wheel direction, light direction, and surface normal. Okay? So which means we need this 3 part. Now we have the light direction. Sorry, we have the light position, and we can calculate the light direction. But we don't have we have this light direction, but we don't have the wheel direction, which can be get easily. And now let's first get the normal. Okay, we should assign the normal for our vertex, so which means here we should add one more part or one more attribute for surface normal. Let's assign the normal by where it is. So this is the back face, and the normal is 0, 0, minus 1. Okay, this is the z value are all negative, so this is back face, and the surface normal is like this. This is back face, and this is the front face. Why was that? Because if you look at the position, you will find all this z value is negative. It means it's pointing towards the negative position, and this is the positive z position. Okay. So this is a surface normal for these two faces. And now this part. For this face, or this facet, the x value are all negative. So it's pointing towards the left side, because left, the horizontal axis is x, and the -1 or -1 is oriented to the left. Okay, so this -1, 0, 0. So let's find the closest one. Okay, this one. Also, press the Alt key to select and do all this thing. So press Alt key, so you can quickly get this. Press Alt key, release it. Okay, paste. And finally, these two faces. So y is negative, y is positive. Find the nearest one, closest one. Then we get the surface, normal. Now here are the surface normal. Okay, so once we get all this normal, each normal for each phase, so this phase is pointing towards the negative z, and this is pointing towards the positive z, and negative x, positive x, or this is left right, and this is down and point up. Now we try to read this thing. We have to change this a little bit because now we have 9 elements. So this is surface normal. So in order to read the normal, we need to add one more notation, which is for normal. So let's add it here. We add a part called notation 2, which is for surface normal, and we change some of the parameters here. And finally, we enable this parameter. Okay? Now let's go to the vertex shader and edit. So we have one more layout, which is for location equals 2. And this is in, vex 3, and normal. We need this normal to calculate the shading. So in order to pass the normal to our fragment shader, we need log x3, so normal. Okay, it's normal. So if there's out, there will be an in. In is here. So if there's out, there's in. And this normal need to be assigned. But if you can still remember, when we talk about surface normal and 3D transformation, the surface normal need to be modified with the inverse of the and transpose and inverse of the transformation. Okay, so what it means is we need transpose and inverse of transform. Use this to multiply with normal. Okay. So if you can't remember why we need to do this, just check the replay about how we calculate do the 3D transformation. When we talk about the theory, we said the surface is normal need to do some transform to keep it perpendicular to the surface. And in order to do that, we need to reverse the transform and then do the transpose. After that, we time with the normal, we get a new normal. This is how we get the surface normal. Oh, okay. There should be no question. Okay, so next, let's think about the wheel position. Let's think about the light position. We have the light, right? But we have the light position, but we don't have the light direction. In order to have the light direction, we need to have the position of the points or pixel we are looking at. Together, so with that, we can do the minus to get the position. What I mean is, actually, we need one more variable, which is called frag pose. This is also in Week3 frag pose. If we can get the current pixel position and with the light position, we can get light direction, right? So first, how to get the pixel position? It's actually very simple. We do it in this 3 transform times vector 4 just this. We just pay attention to the transform. We don't care about the projection view. Just like surface normal. We don't mind about what kind of projection we use or what kind of view matrix we use. We only care about the transform. Now with these fractals, if we can get the, for example, uniform vector 3 light pulse, right? Let's do it in this way, because we name it in this. So we have this vector 3 light direction equals to normalize, right? We can simply use this light pulse minus frag pulse. We can get the light direction just by using this, if we can have the light position. Okay, so similarly, if we have the view position, for example, if we can have the uniform vector 3 view pulse, we can have the view direction, right? Equals to normalize view pulse frag pulse. It's very simple to understand. We can get this if we have this. If we have the view pulse or view position. Actually, view position is where the camera is. So let's get the light now. Actually, almost have everything except there are one more thing. We will talk about it soon. So we know the shading has several parts. One is ambient, specular, and diffuse. Diffuse is also called roughness. So ambient is simple. Vec3 AMBI. We create a variable called ambient, and we have some value, which maybe 6 is fine. And we use this for this our color. Okay. It's ambient. And the diffuse, we calculate from here. From the equation, actually there's one thing we need is the diffuse. So let's create a structure for the diffuse coefficient. And since roughness and metallic or specular are part of a material, okay, so they belong to these attributes of the material. So one is fuse, and one is specular. We can use this. This is actually material, the diffuse, which is the input. We sure the input is this, and then it's just a translation of the function. If you forget the function, let me remind you here. Where's the function? Shading. Let me find the shading. Okay, yeah, this one. So we have two functions. One is this diffuse. So it's diffuse coefficient times light. We don't have the light intensity and light color at this time. It's okay. And we have the max of 0 together with m dot l. So surface normal dot light direction. This is dot product, and we get the max value of these two. So diffuse equals to max function of dot function normal and light direction, and we compare it with 0 and get a larger one. So Week3 diffuse. Don't worry if we use to diffuse here, because this structure belongs to material. This is diffuse. Is diffuse times our color. So this is diffuse. And finally, let's have this specular. To calculate specular, we need one more variable, which is called half angle. This can be calculated from what we have, which is normalized the view direction plus light direction. This is half angle. And then we can calculate the specular, which just translation about, interpretation about our equation. So it's material specular times. So this is a power function of max function of dot function. This dot function for long and half angle. Here we have 0, and we have a very shininess result. So let's see, 64. Then finally, specular equals to times our color. If we add all these three terms, we get the shading. So shading is color equals to Week12 ambient plus diffuse plus specular, and this is for the Week4. So this is our shader. With this shader, we can respond to all different shadings. Okay, so let's have a rest. We will finish in few minutes, maybe 20 minutes. Okay, so let's have a rest first. 吃。对，打上。就是这个下巴，这一节可以移出来，然后其他的往这边可以。我们实际上就是因为这个刚好是看75公分，我们就把这一节当成拿出来，最后会在咱现在先放在这边，就是它是紧贴的这样的状态，正好75公分的这个 Okay, so let's go back and finish this part. We have only few lines of code left. Okay. So first, we need, let's see what we need. We need light post, wheel post, and some of the materials. We have the light post, right? Light post is here. I think, yeah, light post is here. We have the light post. But we don't have the wheel post. And the wheel post is the camera. It's camera position. So in order to have the wheel post, we can roughly quickly do it by return the camera get position, camera position. It's a getter. We can return this position. Okay. Now we have everything. Let's go to our shader. And yes, let's go here. Now let's parsing all these variables one by one to our shaders. We need to parse like, let's see, light post, wheel post, and the material. Okay, so let's go to this part. And parsing each variable. So first light post and uniform 3F. So first is the light post and the wheel post. Get program light post, and we parse the light post. X light post dot Y light post dot Z. Now we parsing the light post. And similarly, let's do it for the view pose. So this is view pose. Now we have this is camera get position, camera.get positions, each of these for X and Y and Z. Okay, now we have this. So, how about you make it? Okay, so finally, let's do it for the shininess and the specular and diffuse. So which is uniform F get uniform There are plenty of ways to do it. Let's do it in a simple way. Material, diffuse, and we give it 0.8. Similarly, specular. This might be a little smaller, so we can see something clearly. Okay. Okay, so let's run the code and see if we have made some mistake. If there's no mistake, we can see a shiny thing. Oh, seems there's one mistake. Let's see what's going on. Use normal material shaders. It's a fragment. Oh, okay, yeah. This is material. Seems to be there's still some mistake. Norm. M-A-T-R-A-L. So let's check what's going on. Okay, yeah, I know what's going on. I should write nothing this way, but the uniform material. So this is data type, and this is a variable material. Uniform material. So this norm is not defined. Oh yeah, I don't have the normal. Sorry, I use normal, not norm. My bad. And actually, norm is normalized. Normal. Okay, so here I need to add this and this. We will see how it works. Just give you a few time to type it. Let's run it again and see. Okay, still one more mistake. 29 use undefined. Okay, go back 3. Sorry. Check if still. Okay, yeah. Now actually I can see some shiny thing, I think. Oh, this goes further away. Let's go back. Round it. The middle cube is too small, so I can't see it quite clear. First, I will give you a few minutes to type this. Then let's fix it. Okay. Let's fix this by increase the size of the middle cube. 1.5. So increase 9 times to see if we can see clearly cube. Right. Now you can see it has some shiny part. Yeah. The shiny part represents the light. Right. If the light goes here, goes somewhere, we can see this shiny part. This means this shiny of light, point light. You can see all this shading changed on the surface of the cube. And at a certain position, you can see there is one white spot, which means this is specular. Okay, we use this to simulate the lighting and the material. Okay, so this is the code for everything. We try to finish this. I mean, this is everything we need to talk in this course. Because we have limited time and also because we have all the offline course. Okay? So check all this code and finish it. This is the part we mainly changed in this area, and also some of the codes here and here. Okay, so I'll stop here for a while. Let you double check with all this. Please pay attention to this this typing. Okay, so because if you make any mistake about this variable's name, you will have a black cube. A black cube or non-cube. If you didn't see any cube, it means you might have some mistake here. You might misspell something, so there's nothing has been parsing from here to the shaders, so all the value are 0. So pay attention to here, and then I will jump to the fragment shader and vertex shader, because once you have some mistakes there, you will still have you will still see nothing, because 0 is parsing to it. Okay, then I will jump to the fragment shader, vertex shader. Pay more attention to all this spelling. Okay, this is. Because if you spell anything, even like the capital letter or lowercase or some letters you're missing, you will have black or nothing. A black cube or no cube. If it happens, it means you have some spelling wrongs in these two shaders. So just check it. Once you finish that, we can finish this class. Next time, on Thursday, which is our final class, I will give you the assignment for the final project, and you will have 3 weeks to finish that. Okay, so you will see your grades before Christmas. Okay, so stop here. Just let me know if you have any questions. I will still be here. 你好，你稍微等一下，我现在有个事儿，过半小时再见。It's too late to submit the previous homework, but for the final homework, which means if you can remember, I think that's the changing texture. I can still check your homework if you finish that part, but for the previous homework, it's too late. It's long overdue. It's my 2 months late. Okay. Not 2 months late, but at least 1 month late than the deadline. So I may suggest you to spend some time to see if you can finish the last homework, which is changing textures. If I'm right, and double check. No, it's too late. You know, in our in computer science, I mean, if you work in some company and you have some contract, if you're late for the deadline, you will be fined about 3% of the over the you will find about 3% about the project money if you're late for just 1 day. So it means if you're late for more than 1 month, which means 33 days, you will get nothing because of your fine. Okay? Because of the punishment. So that's why in our major, we need to keep the deadline in mind. Okay? What kind of list? Sorry, I didn't get it. What kind of list you want? I just think many of us can't send on time. I don't know. Okay. We have 4 homework, right? Okay, I will type it here. We have 4 homework. The first, if I'm right, the first is the triangle or rectangle. I can't quite remember. The second one is which I give you. Second and third one is you want that. Let me check. I think that might be the one. Let me create these things for you. I can't see. Okay, it's not that clear. Let me do this in this way. The list is for homeworks. We have one final project. For the final project, if you can finish the coding, you will get higher score. But if you can't finish the coding, you still need to write a report to get some basic score for this. Okay? If your name is not honest, it means you might be very late for the homework. Basically, if you're late for less than 10 days, it still counts, but I will say it is late.喂，明天下午是教2301是吧？好的，行，这个无所谓，行。 Okay, so that's it for today's lecture.